What if I told you that the greatest achievement in human history might be just a carefully made act? Did humans really go to the moon? Or did we believe the biggest lie in history? On July 20th, 1969, NASA announced the success of Apollo 11 and the landing of the first human on the moon's surface. Neil Armstrong said his famous line, "This is one small step for man, one giant leap for mankind."
It's one small step for man, one giant leap for mankind.
But from that moment, the doubts began. And today, we will break down the most dangerous conspiracy theories one by one. The flag shot in the Apollo 11 mission is one of the most used scenes to raise doubts about the moon landing. Some skeptics saw the flag's movement as clear evidence of wind, which means, according to them, that the scene was filmed inside a studio on Earth, not in a place with no air. This claim is based on observations that, on the surface, seem logical. The flag can clearly be seen moving, and its motion looks like cloth rippling in the wind, continuing for several seconds. Based on that, they consider what we see to be direct visual evidence of air, and therefore it would be impossible for the footage to have been taken on the moon. But when we look at the details, the picture changes completely. In reality, the flag used was not an ordinary piece of cloth. It was specially designed to look stretched out in an airless environment. It was attached to a horizontal rod at the top, while the fabric itself was not fully stretched and had visible folds. When the astronauts planted the flag into the lunar soil, they had to twist and push it firmly into the ground, which caused a mechanical vibration in the cloth. Here is the key point. In the absence of air, there is no resistance to slow the movement quickly, as happens on Earth. As a result, the flag kept vibrating for longer than usual, giving the false impression that it was waving, when in fact it was only a natural vibration of an object moving in a nearly frictionless environment. And this was not only a theory. NASA actually tested this effect inside vacuum chambers that simulated the moon's environment, using the same flag design and the same mounting method. The results showed that the flag vibrates clearly when moved, and keeps vibrating longer than it would on Earth, with no wind at all, just pure mechanical motion. Even with this clear explanation, some clips helped spread the wrong idea, not because the evidence was strong, but because of how the footage was shown. Some supporters of the "humans never went to the moon" theory cut the video and removed the moment when the astronaut touches the flag, making it look as if the movement started by itself. They also ignore the direct link between the astronaut's action and the start of the vibration. Since the Apollo 11 photos were shown to the world, many people noticed a small but controversial detail: a completely black sky, with no stars at all. This opened the door to many questions. If astronauts like Neil Armstrong and Buzz Aldrin really reached the moon, why did the stars not appear in the photos? Isn't space full of them? And shouldn't they be even clearer without an atmosphere? For some, the answer was simple. These photos were taken in a studio, and the black sky is nothing more than an artificial background. This explanation seems logical at first, especially when compared with what we see at night on Earth, where the sky shines with stars. But this comparison, even though it seems simple, has a basic mistake. It assumes that a camera works like the human eye, which is not true. In reality, the photos taken by NASA were not meant to capture the sky, but to show the moon's surface, the astronauts, and the equipment. To do that, the cameras had to be set in a way that matched the brightness on the moon. The moon's surface reflects sunlight very strongly, and the astronauts' white suits make that reflection even stronger. That is why special camera settings were used for very bright objects, such as a fast shutter speed and a narrow aperture. These settings make details appear clearly, but they also stop faint objects like stars from being captured. In other words, the stars were there in the sky, but the camera could not record them. To understand this more simply, we can go back to a normal, everyday example. When we take a photo in broad daylight, the sky looks clear and blue with no stars, even though the stars are still there. The reason is the same. Strong light hides faint objects from the camera. And if the photographers on the moon had changed the settings to show the stars, the opposite would have happened. The image would become overexposed, and the lunar surface and astronauts would disappear in extreme brightness. Some online clips also misled viewers by showing the photos without technical explanation, or by comparing them with night photos from Earth, which is not an accurate comparison. This kind of presentation strengthens doubt, but it ignores the basic rules of photography. It is also important that the astronauts themselves said they were able to see the stars, but not while working on the moon's surface, where the bright sunlight made them hard to see. In the end, it becomes clear that the absence of stars in moon photos is not proof of fraud, but a natural result of camera settings and the harsh lighting conditions on the lunar surface. It is purely a technical issue that, over time, became one of the most famous debates in the history of space exploration. Among the most controversial questions about moon missions is one that seems logical and frightening at the same time. How did humans leave Earth and pass through regions filled with deadly radiation without being destroyed? This question is linked to what is scientifically known as the Van Allen radiation belts, which are regions around Earth that contain high-energy charged particles. Skeptics start with a real scientific fact. These belts do exist, and they contain high levels of radiation. From that, they conclude that any attempt to pass through them, especially in the 1960s, would have led to disaster. In their view, the technology at that time was not advanced enough to protect astronauts from radiation that could be deadly in a short time. This idea sounds convincing, especially when we think about the fear linked to the word radiation and the serious health risks it suggests. But the problem is not that the belts exist. The problem is how the danger is understood. When we go back to the details of the Apollo missions, such as Apollo 11, it becomes clear that crossing these regions was not random, but carefully planned. Specific routes were chosen to pass through the less dense parts of the belts, and the crossing time itself was relatively short, which greatly reduced the amount of radiation the astronauts could receive. In other words, the astronauts were not living inside these belts. They passed through them quickly and in a controlled way, and that is a very important factor in reducing risk. Radiation exposure depends not only on how strong it is, but also on how long the exposure lasts. As for protection, even though the technology at that time was not as advanced as it is today, the spacecraft were designed to give some radiation shielding. The metal structure of the spacecraft helped absorb part of the harmful particles, and the design was meant to reduce the effect of radiation as much as possible. The data shows that the radiation doses the astronauts received were higher than normal levels on Earth, but still within non-lethal limits. This matches our current scientific understanding, where the real danger of radiation comes from long or intense exposure, not from passing quickly through a radiation zone. Even so, some theories still present the Van Allen belts as a deadly barrier that cannot be crossed, while ignoring key factors such as exposure time, route choice, and the partial protection inside the spacecraft. This kind of argument tends to make the danger seem bigger than it really is, without showing the full picture. In the end, the Van Allen radiation belts are a real challenge in space travel, but they are not an impossible barrier. With careful planning and understanding the nature of radiation, humans were able to pass through them safely enough, as shown by the Apollo missions that reached the moon and returned. And so, one of the most frightening theories becomes another example of how misunderstanding science, or presenting it in an incomplete way, can lead to conclusions far from reality. The issue of shadows became one of the strongest arguments used by skeptics. In Apollo 11 photos, some people noticed that the shadows did not always go in the same direction, which they took as proof that the scenes were not filmed in a natural environment, but inside a studio with multiple light sources. This claim starts from an idea that seems logical on the surface. The sun, as the main light source in space, sends out rays that are almost parallel. Based on that, the shadows it creates should also be parallel. But when looking at some photos, it seems that an astronaut's shadow points in a different direction from the shadow of a nearby object, and some shadows even appear to cross. For some people, this can only be explained by more than one light source, like in a photography studio. This conclusion ignores important factors related to the surface and the viewing angle. Unlike what the photos may suggest, the moon's surface is not flat. It is full of craters, ripples, and small slopes, and these affect the way shadows form. When light falls on an uneven surface, each part of that surface casts shadows differently, which makes the shadows look non-parallel, even though there is only one light source. In addition, perspective plays a big role in tricking the eye. The images we see are two-dimensional versions of a three-dimensional scene, and this can change how we understand the direction of lines and shadows. Even if the shadows are parallel in reality, the camera angle and the distance between objects and the camera can make them look like they cross or go in different directions. It is the same effect we see with straight roads that seem to meet at a far point. There is another factor that is often ignored: light reflected from Earth, known as earthshine. Earth, as seen from the moon, reflects sunlight and provides a faint secondary light. This light does not create strong new shadows, but it reduces shadow contrast and shows details in areas that would otherwise be completely dark, which may give the impression that there are extra light sources. Why NASA did not return to space? One of the most common questions when discussing moon missions is, if NASA succeeded in reaching the moon in Apollo 11, why have we not returned there for decades? For some, this seems like proof that the first mission never happened. But the reality is that NASA landed several times, and missions reached all the way to Apollo 17. All were successful and were broadcast live on television, where astronauts were sometimes seen playing golf and sometimes driving a vehicle. After the Apollo program ended, U.S. priorities changed a lot, especially as the Cold War became less intense, since it had been the main force behind the space race. The cost of lunar missions was huge, and the government started preferring to spend money on other projects like the space shuttle and space stations. Also, there was no urgent scientific or political reason to return right away, especially after achieving the first accomplishment. Today, interest in the moon has returned, and the race has appeared again, not with the Russians this time, but with China, which is trying to land on the moon before 2030. America is working on this through the Artemis program, where astronauts went to the moon in April 2026, orbited it, and returned safely to Earth. Artemis 3 and Artemis 4 are planned to land and walk on the moon in 2027 and 2028, but this time not only to prove the ability, but to build a permanent presence and explore it more deeply. Here we can see that NASA's delay in returning was not because of weakness, but because priorities changed. Beyond the images and footage that created debate, there is a set of strong scientific and technical proofs that support the fact that humans really reached the moon during Apollo 11. And these proofs are hard to deny because they do not rely only on a story, but on measurements and experiments that still exist today. One of the clearest pieces of evidence is the laser reflectors left by the astronauts on the moon's surface. These devices work like mirrors that reflect laser beams sent from Earth, and they were installed during Apollo missions by NASA. To this day, scientists use these reflectors to measure the distance between Earth and the Moon very precisely, by calculating how long the laser beams take to go there and come back. What is interesting here is that these experiments are not done only in the United States. They are carried out in scientific centers around the world, which makes them independent evidence that is difficult to question. Another proof is the lunar rocks brought back by the Apollo missions. These samples, which weigh hundreds of kilograms, were analyzed in many laboratories around the world and showed properties completely different from Earth rocks. They contain isotope ratios and elements that cannot form in Earth's environment, along with signs of long exposure to cosmic radiation that cannot be easily copied. These samples were shared with countries and scientific institutions, which makes fake samples or replacements almost impossible. Later technological progress also made it possible to confirm the landing sites directly. Modern spacecraft, such as the Lunar Reconnaissance Orbiter, took high-resolution images of the landing sites and clearly showed the remains of equipment left there, including vehicles and astronaut footprints. These images match the locations NASA announced decades ago, which strengthens the original story. International testimony is also important here. During the Cold War, the Soviet Union was the United States' main rival in the space race, and it had advanced technology to track signals and space missions. Still, it never officially denied the moon landing, even though proving it false would have been a huge political victory against the United States. That silence itself is seen as strong evidence in the context of the intense competition between the two powers. In addition, the communication signals between the spacecraft and the astronauts were recorded directly by several stations around the world, not only by NASA. These signals could be detected by amateurs and independent stations, which means the event was not locked inside one organization that could manipulate it. In the end, when we put all this evidence together, from ongoing scientific measurements to geological samples to modern images and international testimony, the full picture strongly points to one truth. The moon landing was not just a story, but a scientific achievement documented from many angles and very hard to deny. If you enjoyed this video, don't forget to subscribe and turn on the bell because what is coming next will be even more exciting and mysterious. And write in the comments, are you with the truth or do you still doubt? See you in a new video.